Okay, so this talk, POW. I was messing around on a pen test last year and ran across a situation where a PHP application had some weird stuff showing up in the headers. I'm an appsec guy, in case anybody doesn't know that yet. And I noticed, hey, look at this. It's like serialized PHP objects, and that made me go, okay, well, this is kind of interesting, because up until that point, most of the serialization that we'd run across had been just in Java. We heard about Java serialization flaws all the time. But this is the first time I started realizing that it's actually across multiple different types of languages. So this is me actually thinking about this talk. I took this picture while I was thinking about the talk, contemplating how am I going to do this. Because what I wanted to do is I'm sure some of the people in this room have probably played around with ysoserial before. That's not what I'm going to be doing here. But the point is, when I looked at that stuff, I found that it was pretty complicated. Right? It was a little overwhelming. And I've been a developer doing Java stuff pretty much since Java came out. And if it was complicated to me, I imagine it's probably complicated to a lot of other people too, especially anybody with mostly network background, hasn't done a whole lot of programming. So what I wanted to do was put together a talk that could kind of bring everybody up to the same level so we all understand object-oriented design and how that contributes to these deserialization flaws. So I put together a couple of demos. I'll show those later. So other things about me that are relevant to this talk. I am a consultant with Secure Ideas, as was mentioned earlier. I do a lot of pen testing, mostly application security. And I'm a home brewer. So that's the most important part. I love home brewing. So I mentioned why I was going to talk about it. Deserialization flaws are still very relevant. In case anybody missed it, I don't know if you can see this, but this is the CyberArk, I'll read it, hang on. The REST API and CyberArk password vault web access before 995, et cetera, allows remote attackers to execute arbitrary code via serialized .NET object. So they didn't say deserialized, but they mean it's a deserialization flaw. This came out this week. This was announced just this week. So this is brand new stuff. It's still happening. In the past year, probably the biggest breach that was on everyone's mind is Equifax. That was also due to a deserialization flaw. This one was Java. It's part of that struts API, one of several issues with struts. And that was really, really bad, right? Everybody heard about it. Everybody talked about it. And they're not going away. So just out of fun, of course, to go over to CVE details and do a little search there. And I searched on deserialization. So that's not a very common term. I can only think of one place where you would use it, which would be a deserialization flaw. And I don't know if everyone can see that. 1,680 results. So 1,608. Now, some of those are probably just describing what is deserialization or something like, or what the flaw type of flaw is. But a lot of those are going to be actual deserialization flaws that were found inside of various different products. It's inherent inside of frameworks. That's where you're going to run across it. And then frameworks are used in a lot of products, so a lot of the same flaws end up in a lot of places. And also, if you scroll down those results, you'll see that many of those CVEs are 2018 CVEs or 2017. Like these things are rampant. So it's not going away anytime soon. And this is the kind of thing that made me really think about what I wanted to present here, because it's not going away. And why isn't it going away? Like, can't we just fix it and move on? But we can't, not really. And that's what I'm going to talk about here. So in order to understand what is a deserialization flaw, the first thing I want to do is kind of get us to what it really is serialization and why do we have it? What do we mean by that? So the dictionary definition is arrange in something in a series. So why would we need to do that when we're programming stuff? Nobody? Storing stuff, that's right. So if we're gonna store stuff or we're gonna transmit stuff, right, transmitting or storing, we need to serialize it first because we wanna put things in a predictable order so that at the other end of whatever we're doing, either loading it back from a disk or receiving it on the other end of a transmission, that we can put it back into the right order so that's the same data that we started with, right? It's very simple. But that is what serialization is about. So where do they come from? Deserialization flaws, where do those come from? It comes inherently from one specific area of programming, which is object-oriented stuff. Right? That's where all of these flaws are coming from. It's always object-oriented languages, which is an area that I've spent a lot of time in. So object-oriented, the concept of object-oriented programming has actually been around since like the 1950s, Lisp, right? That's where it first came out. But it really started to gain ground probably in the mid-'80s to mid-'90s, where we had object-oriented was a buzzword, right? It was object-oriented architecture, object-oriented design, object-oriented programming, object-oriented methodology, which is where the title of the presentation comes from. So you had people like Grady Booch starting to make this into a design methodology and a way of building out architecture. There are some huge advantages to object-oriented design. And that's kind of why it gained so much popularity. It wasn't just a buzzword. I mean, once it started gaining ground as a way to design things, it pretty much stayed there. And even today, a large portion of the software that's out there right now is all based on object-oriented design. So it's one of the main things. I mean, it allows us to have some abstraction. I'll get into a little bit more what that is, just in case there are still people in the audience who aren't really sure what I mean by object-oriented. But we can basically, in our design, represent real-world objects in a way that makes it easy to code around them. It's very modular, so you can have you can like break it down into modular pieces and just work on one little bit here, one little bit there, one little bit over here, and then it all kind of fits together nicely. So much so that one of the biggest advantages to object-oriented is that huge teams of developers, or like multi-teams of developers, could design a large system, break it up into separate little object areas, work on everything independently, and then at the end of the day, they stick it all together and it somehow magically actually works. Okay, it's not really that easy. I mean, we all know that, right? But you get the idea. Can you imagine writing some of that same code you have 100 people working on it in a procedural language? Can you imagine doing all that in Perl? Yeah, that'd be really hard. So the other thing with object-oriented languages is they tend to be strongly typed. Like that's part of how the object-oriented design works. We define what things are, and then we make objects of those. So looking at an example here, I'm going to start really simple. I'm going to build this out just a little bit. And hopefully, if there's any doubt in your minds as to what I mean when I say object-oriented design, that kind of goes away by the time I get to the third or fourth slide here. So this is a class diagram. All right, we're talking about not objects. These are the templates for creating objects. Everything inherits from the class object. So all objects, funny enough, actually come from the class object. Now in this case here, in this system I'm building out, I have container and liquid. I felt that was appropriate for this conference. So containers, let's just say they have an attribute. Capacity, it's an integer. So now we're starting to talk kind of code-like stuff. Now I haven't created any containers yet. This is still the class container. So we're saying all containers have a capacity and all liquids have a volume, an amount of liquid. And a container, you can fill it with liquid and you can pour out liquid. So those are two actions that we can perform on a container. All right, so let's drill down a little bit more on what we mean by containers. All right, so at the top there, that container, that's the same box I had before in the previous diagram. So now I'm saying that there's different types or different subclasses of container. So we have a glass, which is basically just does everything a container can do in this case. We have a different type of container, which is a keg. That's a really cool container, because a keg not only allows you to pour stuff out or pour stuff in, but you can also hook it up to a gas cylinder and dispense it, and it's all bubbly and really cool. I like that. And then we have, in this one, a bottle as well. Now, a bottle extends an interface that's a bottle cap, so it allows you to actually open it up with a, you can remove the bottle cap. Okay, so now let's take a quick look at liquid. I'm just keeping this really simple intentionally. So we have liquid, it has a volume. Now we're going to subclass liquid, and we're going to give it some additional attributes. ABV, so alcohol by volume, it's a float. And we have IBUs. So everybody who's really into real beer knows what IBU is, right? So for those of you who are drinking a Bud Light, I'm sorry. But IBU is an integer going to be between 1 and 100. Okay, international bittering units. And then we have ales, ciders, and meads as different types of brew. They're all brew, but they're actually different subtypes of brew. Now, in this diagram, I've decided, okay, now that we have some idea what our object classes are, let's actually create some objects. So we have the darker blue box in the middle is an object that I'm calling a pint glass. Now, that would be the variable inside of your code. It'd be a pint glass. And it is of type glass, which extends container. So it has all of the attributes of container. Not only that, but we can now assign actual values to it because we have an object in memory, okay? Same thing with, at the bottom, I have a type of ale, and I'm just gonna call it a pint, so that way I have a pint of ale. And it has all of the attributes of a brew and a liquid, and basically everything up that chain. And those two are related. One actually contains the other, okay? So everybody with me so far? So, now that we have an idea of what our object structure looks like, we need to figure out how do we transmit or store it for later purpose. So we have a pint of ale, and we want to store it or transmit it from point A to point B. Now, there's a couple of ways we could do this inside of a program. The first way, and this is, I guess, sort of the traditional way we think about serializing something, is we take all of the data that makes up those objects, or the data structure, and we save it all in a particular order. So the capacity, the volume of the liquid, the ABV, the IBU, we would take all of those attributes and we would store them or send them all in a certain order. And then on the other end of whatever we're doing, so let's say we're receiving a transmission, we would know that we're receiving them in that same order, right? So that's traditionally how serialization might occur. Some big problems with this, especially in an object-oriented world. In an object-oriented design, I can very easily change things. That's one of the advantages of object-oriented is further up it could be not just the class that I'm serializing, but it could be one of its superclasses that I change. Maybe I add an attribute to ales. Maybe I say that they have a color or an amount of carbonation, or maybe I change a container and it has a material that it's made out of. Right? So now I've made it more complex. Now any code that I have that serializes it, I need to rethink that, put things back into a different order, and basically I keep adding more and more lines to this, both on the sending side and the receiving side. Option 2 is, well, why don't we just make that part of the language? And this is what every object-oriented language I've ever worked with does. It has a single call, a single function that says, write this object to this output stream, or read this object from this input stream. And it just auto-magically does everything for you. It's on autopilot. So that's basically where our serialization comes from. It's the easy way, it's the lazy way for us to do things. It's automatic. We don't have to think about it, right? So a lot of languages do this. Java, PHP, Python actually has a serialization capability in there. It's called Pickle. Ruby, I don't do anything in Ruby, but I understand it has serialization and also deserialization flaws. Even JavaScript does. All right, so what I'm going to do now is go through a couple of contrived examples. This is sample code that I put together. I also put it out on GitHub so you can play with it later if you want. It's basically just to kind of show how the serialization, deserialization works and how we can introduce a malicious payload or at least changed payload into a mechanism that's doing deserialization of objects. All right? So let's consider, this is, like I said, it's contrived, made it up. We have a ticketing system. And part of this ticketing system, the first thing it's going to do, we're going to have the creating a ticket or generating a ticket capability on there. And I'm just going to put some very simple information in there. Let's see here, hang on a second. So here is the sample stuff. And I'll go through the code after. First, I'm just going to show you what the app does so you have an idea. So I'm creating a ticket. It's cut off there a little bit, but it's my first and last name. And then when I submit that, it generates the ticket. And we have that weird string at the top, which I will walk through that in just a second, which then I base64 encode that ticket. So now I have this information here, which is the ticket for this ticketing system. This could be event tickets, it could be trouble tickets, whatever, it doesn't really matter. Now, if I go back here and submit the ticket, so think later on down the process, maybe the user who submitted a ticket receives an email or gets a link or whatever, or scans a QR code in an event. That same ticket value gets submitted, and then it gets, when it's submitted, the base64 encoding, it decodes to its serialized value, which we can then deserialize and show the information on it. Okay, so let me jump back to my slides for a second. So a couple of things I want to mention. So first of all, what is that weird string that I was showing? That's serialized PHP. So this example is in PHP, by the way. And this is what I noticed when I was doing my test last year. I saw this going back and forth between the browser and the server, and that's kind of what made me go, okay, that's interesting. It's not JSON. That's what I was when I first caught a glimpse of it, I was like, oh, it's JSON. No, wait, no, it's not. That's weird. It's got all of these colon delimited pieces to it. Each string in there starts off with an S to tell you it's a string, and then it gives you the length of the string, and then it puts the string in there. And so then I delved into this in more detail, and then kind of pulled it all together and went, oh, okay, that's cool. And you'd think that somebody who's been doing application security for many years would have encountered this already, except I almost never test any PHP stuff. Like most of what's out there is not that I'm testing isn't PHP, because I do a lot of stuff in the enterprise, and you don't really find that very often. But this was the first time I encountered a PHP app that was actually serializing these things back and forth from the browser. So I was like, okay, that's interesting. Let me look at that. So this is what we're doing to generate the ticket. Very simple. For those of you who know PHP, you should already understand this. For those who don't, I'll walk through it very quickly. So we have our ticket data, okay? And for that, what we're doing is we're creating an array. It has my first and last name that comes from the post. So this is when I typed in the first and last name in that form field and then hit submit. This is the file that gets called after that. All right. So it's taking that information, putting it into an array. It's calling the PHP built-in function serialize and passing in that ticket data. And then what's coming out of that is the serialized version, which I then echo out in base64 encoded form. Right. So just base64 encode it to make it safe for the web. That way I can put it inside of cookies, I can put it into URLs. I don't have to worry about any special characters in there. All right. Next, we have the submitting of the ticket. So this is the second form where I just took that blob of base64 encoded stuff and put that into that second form. And it's basically just doing the opposite. It's very simple. So it's first thing I'm doing is I'm base64 decoding that value. So that gives me my serialized object. and then I unserialize that, and that gets me back to my array, and then I can output that data from the array back into onto the screen so we can all see it. We can all read it. Make sense? Okay. Here's the catch. We do include a vulnerable.php file. Now, I will tell you right now, you're probably not going to find, as you're doing a test or something, that you're going to find a file called vulnerable. It's not going to be that obvious. But so in the contrived example, it is. I try to make it very clear where the vulnerability is. So we have this vulnerable PHP. This was included in this file, which means if it has any vulnerabilities, we can make use of them inside of the PHP here. And in this case, we can. So before I do that, let me just discuss something very quickly, because this is a key concept in object-oriented design when you get to serialization and deserialization. And that's the idea that there's parts of that run automatically. And you can usually override for special cases in there as well. So remember how I said we have the write object, and you just basically say, hey, yeah, take this object and just write it out to the stream, however you're supposed to do that, and Java just figures it out, or PHP just figures it out automatically. You don't have to do anything else. Now, there was always special circumstances when you're writing code. Developer will find, hey, you know, I'm trying to read this object in, but I need to go fetch this other resource that wasn't available when I saved it, but I need it again, or I need to validate something, or whatever. And so every language that does this also has this concept of these magic functions. And in PHP, there's two magic functions. There's actually more than two, but the two that we're concerned with are sleep and wake up. So sleep gets called automatically when you serialize an object, and wake up, of course, gets called automatically when you deserialize an object. All right? So you have your stream, blob, whatever, and when you deserialize it, if there's any objects in there, the wake up function for those objects is going to be called. Okay, so our vulnerable class, I kept it as simple as possible. It has one of these magic functions. It has a wake up function. So that means upon deserialization, if I have this type of object in there, it's going to get, the wake up function is going to get called. And in this case, the wake up function does something really dumb. But I've run into this. Developers do dumb things. So if the hook parameter has been set, then we're just going to call eval on whatever that is. Now in this case here, our developer thought they were being clever because hook actually is private. It's declared as private. For those of you who are not that familiar with object-oriented design, usually private means it's only available from inside that class. You can't call it from outside. You can't get a handle onto that and do anything with it, usually. So going back to the deserialization of the ticket, we had this base64 code, and then we have this unserialized. So the question is it possible to put something else in there other than the array that it's expecting? And the answer is, yes, of course it is. Otherwise, I wouldn't be here doing this talk. So how do we do that? We have to create an object. All right, we have to create one of those vulnerable objects in there, and then we have to inject it. So I created a tool in PHP for creating this type of object. And it should actually work for anything, probably. I don't know. We'll see. What it's doing is, it's taking the class that I want to create, and notice that I'm only referencing it as a string. So I think, hang on, do I have, yeah, oh, I have a mouse. Okay, so right here, I'm only referencing as a string, vulnerable. So I'm ignoring the fact that this is an object-oriented language and I have strong typing available to me, and I'm circumventing that with some other mechanism called reflection, and I'll get more into that in a minute. All right, so then I am getting the hook property, again, out of that object, and I'm setting accessible to true. Does anybody know what that does? Remember how I mentioned we had that private keyword on there? Well, this basically gets rid of it. It says, okay, never mind, we can go ahead and access that variable now. So now I can create an instance of it. And this is the one place actually where PHP isn't so strongly typed. And then I can set the value on my property, and I'm just going to give it PHP info. That's something that's very obvious in PHP applications to show that you're able to execute other stuff. And I'm going to base64 encode that, so now I have my string back and move on from there. All right, so let's take a look at this. Hopefully working. All right. So here's the tool, and I actually modified it afterwards. I made it a little more parameterized, so we could put other things in here if you wanted to. And when I submit this, it pulls out that together, it sets the accessible flag, it sets the hook, and then generates the base64 encoded stuff. All right, I'm going to copy that. And then I'm going to go back to where I'm submitting the ticket. And if it works, we got PHP info, right? So very simple demonstration of how we're able to take, now we have this different serialized value on here. This looks nothing like the array we passed in the first time. In this case here, we're actually specifying the object that we made up and put in there. So where you're going to run into this sort of thing is if you have a PHP application and it's including any files that are handling, any files that have magic functions in them that get called automatically during deserialization or serialization, and you have serialized objects of any type being shipped back and forth between the client and the server, then there's the opportunity, maybe, to make this work. Make sense? Did I lose everybody? Okay, cool. All right, so it is highly contrived. In PHP, there's a lot of, it's sort of a corner case. You know, it's going to be really hard for all the stars to align because of the fact that it's a templating language which you only have whatever's in scope. So it's only whatever you've included that's available in any given PHP file when you run it. In Java, on the other hand, things are different because we have Java people out there. Some of you, yeah. So in Java, you have access to anything in the class path. So for those of us who have done web applications, that's lots and lots and lots of stuff. Usually the class path ends up being huge. And from any point inside of a Java application, you can access anything in the class path. So the reason all of this works so well and why we've had so many Java deserialization issues is because of another language feature called reflection. This is part of object-oriented languages as well, because what's happened is without reflection, let me just go through an example here. So without reflection, everything's strongly typed, okay? So if I want to create and fill a keg of ale, I need to create an ale object, create a keg object, and notice that they're strongly typed. And what I mean by that is see how it defines the class right in front of the variable, right? It's that capital keg, capital K on the keg. I'm defining that the keg is of type type keg class. It has to be. If you don't, it's going to fail during compilation if you put something else in there when you create it. Okay. And then I can fill it with the ale. And fill works with any liquid, which includes ale, right? We defined that in our class diagram earlier. So again, if we tried to fill it with something other than a liquid, it would break during compilation. It won't even let you compile the file. So it's a strong typing basically prevents you from making mistakes. Now let me go here. Okay, so we can do the exact same thing I just did, but using reflection inside of Java. So Java has sometimes it's also called introspection. They're not exactly the same thing, but reflection. With reflection, look at this. Look at the code that's on there now, and you will see that nowhere on here am I using any of the types for the class system that I built. Liquid is not on there. Ale isn't on there. Keg isn't on there, except as strings. Everything's a string literal. So the only classes I am defining are class. So I'm using the class, which I know it sounds weird, but that's the way it works. And I said, build a class for name keg. Then I'm saying, okay, well, now that we have one of those, create a new instance of an object with that. And again, I still have not used the strong typing. Then I'm going to create the method fill. I would set up some arguments and then call method.invoke on that object. So the arguments, whatever I've defined, that will actually run that function call. It'll run fill because that's the method that we've defined. Okay. So what we've done here is we've taken a language that had this really great feature in there, strong typed, and we basically threw that out the window. We said, okay, let's not do that. And in fact, what happens here is developers basically said, okay, well, I know it's strong typed and that's really cool, but it would be really awesome if I could make it so I could make my application run anything. Right? I could just run like arbitrary stuff and send it to it. That would be really cool because then I don't have to recompile. That would be awesome, wouldn't it? And of course, us being security people look at that and go, yeah, that would be awesome. So, and that, that's exactly what leads us to this problem. So, if you've looked at the ysoserial stuff before, you will have run into this term called a gadget chain, because that's one of the main things that came out of the Apache Jakarta Commons Collections API. It's a mouthful. Commons Collections API. That's a vulnerable library, one of several vulnerable libraries that do this sort of thing. And so what I created here is I basically mocked up a simplified version of a gadget chain. So it's a little easier to understand, but it basically does the same thing. Okay. So if you consider key value pairs, so just like a dictionary or a hash map or whatever, except that they are set up for basically the elements that you need to call a function somewhere. So you have a method, parameter types, parameters, classes, each of them defined as, so the key is a method, and then you give it the name of the method. The parameter types would tell you which parameters you need. The parameters themselves is going to be a list of what the values are you're going to pass in there. The class would be the name of the class. All of these are by name. It's string key value pairs is what I'm talking about. That is what makes up our gadget chain. And we can chain multiple of those together in order to, with some clever logic on the back end, that's what we find inside those vulnerable libraries, to actually do stuff, to make it execute just about anything. Okay, so the goal that I have here, I was going to start off with, well, why don't I execute something on the command line? And I actually tried that first, and it failed inside of my Vagrant environment that I'd set up for this. And it turns out the reason is because the default version of Tomcat that gets installed with apt-get on Ubuntu, they set up a security profile on there that prevents execution by default. And I was like, okay, I could disable that because in a lot of systems it's not enabled. So, but let's go with something that we know works, that I can still demonstrate. And I'm also running a little bit short on time, so I want to make sure that we have something that we can see easily. So what we're going to do here is we're going to do thread.currentThread, and then step 2 is we're going to make it sleep for 5 seconds. So very simple. All right, so we have, let me just, right, okay. So here is my demo application for this one. Let me just refresh this. Okay, so what's happened is I've created an object that's serialized that is then put inside of a cookie value. Okay, so there's the object that what I did here is just so we can see what's going on. I deserialize it on this page and then print it out. So we have the object is in this case it's a hash map that has 3 values on it: role, timestamp, and username. and then it's basically, you can serialize a hash map just like any other collection. Serialized, put into base64 and dropped into a cookie. I have a cookie editor here, so if I refresh this, we should be able to go and see the cookie value, and here it is right here, okay? Now, I know it's probably not super visible there, and I have it on some slides later on that's bigger, but one of the main telling points in any Java serialized object is you have that root at the beginning, right? The little r, the big O, and the 0. So whenever you see that, that's a serialized Java object, so that's when you start wondering, hey, you know, what's up here? Here's a Java serialized object. Is there something I can do with this? All right, so I have my invoker chain here. So this is my gadget chain, and you can see that it's doing what I described before. I don't know, it's a little bit dark on there, but it's basically the same stuff that I had before. So I have a hash map. I'm adding class and method into that for the Java-lang thread, current thread, and then putting a second element in there for calling that sleep function with a value of 5,000 millis. And then I'm adding those all to a list and then serializing it. So let me just go ahead and run that. Okay. And so that's created a new, make sure I get the whole thing. No, I didn't. Okay. That's creating a new serialized string. It's base64 encoded. This one's much bigger because there's a lot more to it than just a couple of values. I'm going to copy that. All right. And then I just want to refresh this because I know I have a very short timeout on that cookie. Okay. I have set the value to my payload. And then when I go back to this page, if it actually works, when I hit refresh, that cookie is going to load in. It's going to try to deserialize whatever the object is, and it should wait for about 5 seconds before it does something, hopefully. Yep, so it did. So I got a 500, so you might be wondering, well, did it work? Well, yeah, of course it did, because it still waited 5 seconds before it did that. So what happened here is, once it finally did get to my object, it went, oh, okay, it's a class cast exception. You passed in some weird thing I wasn't expecting. I wanted a hash map from you, so I'm going to throw this out on the screen instead. Right, so that's what we get out of it. But the fact is that inside of Java, you can't get to this point here where there's a class cast exception until after you deserialize the object. So the deserialization has already taken place, and any custom code that's in there has already been executed. And that's why we have so many deserialization flaws out there, because we can't really get around it. It's part of the language. It's not, it's part of how object-oriented languages work. It's baked in. And so these types of flaws are going to, I think, probably going to keep popping up for a while yet. So there's some solutions that can work across any of these. One is you can sign objects, right? So you could take the object, serialize it, and then wrap it in a signature that then you check before you deserialize the object, right? So that if you're stuck with serialization and you want to keep it there, that's really what you should be doing. That way you prevent any tampering with it. Option 2 for solution, just don't use serialized objects at all. Replace that with something else like JSON. JSON, I guess it's sort of serialized to JSON, whatever, but it's not object serialization because it's not, there shouldn't be any case where code gets executed as a result of taking a JSON data structure and turning that into an object structure, right? So that's also, JSON's very popular these days. It works across a lot of different platforms. It's gaining huge amount of popularity with web services. So if you're not already working with it, then get used to it. Another one, promptly patch any frameworks that you're using, which, if you're using Java with anything, you should definitely be doing that there. That's what got Equifax, really. It wasn't the fact that they had it was the fact they had the flaw. It was the fact they didn't patch it, because there was a patch available. They just didn't get to it quickly enough. So, and then if you're in a situation where you can apply a security policy, then do so, obviously. That will prevent dangerous behavior should a malicious object enter the system. So takeaways, inherent in object-oriented languages. In many languages, not just Java, I think Java is the first place we discovered it, really. But I think we're going to see it in other places too. There was a .NET just this week with ArcSight. I think we're probably going to see more .NET serialization flaws pop up. It's due to sort of that combination of the fact that during that process, in every language, there's some kind of magic function in there, some way of overriding default behavior. So that's going to be there, along with reflection. Right, reflection allows us to get away from the strong typing. Normally, strong typing you would think might save you, but it doesn't. We can introduce objects that are not actually part of the system that is expecting them, and it'll still blow up, like we saw. We got the class cast exception, but not until after we've already executed. So they do require access to a class that's doing something dangerous or stupid. Those are unfortunately too easy to find. They're around. And so that's it. So my demo code for this is available on my GitHub repo, serial von demo. I'm hoping to, over the next few months, put some additional ones on there. So instead of just PHP and Java, maybe add a .NET example on there. I don't know if I'll brave Ruby or not, but I'll probably put a Python one on there. That's pretty much it. I do have one attribution out there. I just want to say that the marshalling pickles was part of what inspired this. That's the guys who did ysoserial as well. So thank you very much.